Good afternoon. Welcome to our 419 Computable General Equilibrium Models. So today we're going to continue with our simple model first, and then we're going to introduce taxes, different tax schemes, and introduce government, of course, to the model. Let me now share my screen. The last time we were just studying the simple example where we have two goods. You will remember that from the textbooks. I think this is the end of chapter 3. Okay, so there was this specific example with two goods, two factors, and we had these factor prices. Okay, so everybody, so every single endogenous variable were normalized, so prices were normalized to 1, and production levels were normalized to 100. Okay, now what we want to discuss now is the social accounting matrix. So basically, we want to keep track of all the incomes and expenditures in the economy. In the next weeks, we're going to use this concept in a more central way when we discuss our models. But let me show you this. So we have different accounts, right? We have the first firm, the second firm, the first consumer, the second consumer, right? And then we have factors. Maybe I should do this. We have factor 1, factor 2, right? So these are production factors. And we have consumer 1 and consumer 2, okay? Now I want you to imagine a matrix, all right? So the same order, we have firm 1, firm 2, factor 1, factor 2, consumer 1, and consumer 2, right? So this is, as you see, is a simple matrix with the same number of columns and rows, right? Now we want to keep track of all the expenditures and all the incomes in the economy. All right, all the expenditures and all the incomes. And typically, we want to put incomes on the rows, okay? Incomes in rows and expenditures in columns. Okay. Now, if you look at this model this way, we know that firm 1 and firm 2 will have some intermediate input relationship, right? Firm 1 and firm 2 will have some intermediate input relationship. So when we think of firm 1's incomes, okay, we will have an entry here, right? Then we will have perhaps an entry here. Let me just double check. Yes. So what are these? So firm 1 will have some income, okay, from firm 2, because firm 2 will have some intermediate input demand from firm 1. And in the meantime, firm 1 will be using its own output as an intermediate input as well. All right. So two sources of income are originating from the firms, right, for the firm 1. Then for factors, there is no income originating for the firm, right? Because firm 1 is actually paying for factor 1 and factor 2, right? Because firm 1 goes to the factor markets and hire factor 1 and factor 2 from the consumers, right? But then when I am writing the incomes of the first firm, I also have income streams originating from consumer 1 and consumer 2. Why? Because consumer 1 and consumer 2 are just buying the output produced by firm 1. Okay? So that's it. Now what happened? Well, firm 1 produced its output, and it sells some portion of its output to firm 2, another portion to consumer 1, another portion to consumer 2, and the rest is used by the firm 1 itself. All right? So the incomes of firm 1 will be basically recorded in this way. Okay? Now what happens at firm 2? Again, I'm looking at firm 2's incomes, right? Once again, consumer 1 and consumer 2 are going to be purchasing the output by firm 2. Okay? And then again, similarly in this specific example, of course, I mean, this is the simple example at the end of chapter 3. Be careful with that. And once again, firm 2 will be selling some of its output to firm 1. So firm 1 pays something for firm 2. So this part is firm 2's income stream originating from firm 1 because of the intermediate input demand. And then some portion of the output is again used by firm 2 itself. And then consumer 1 and consumer 2 are paying for the goods or services they buy from firm 2. Okay? So that's it. Now then we have factor 1 and factor 2, and these factors are basically accounted as different entities. Okay, so yes, I am the consumer and I own factor 1, but factor 1 is like, I mean, you may imagine that there is a bank account. All right, let's say I have my labor. When I sell my labor to the firm, there is this bank account originating associated with my salary. So the firm pays my salary to this checking account basically, and I obtain my income from that checking account, right? So if you imagine this in this way, let me just double check. Yes, so factor 1, this account will have an income originating from firm 1, right? And also from firm 2. Why? Because firm 1 will be using factor 1. Firm 2 will be using factor 1. Okay? So the income for factor 1 is originating from these two firms. Nothing from itself, nothing from factor 2, nothing from consumer, consumer 1, nothing from consumer 2. Okay? And the similar thing is also true for factor 2. Why? Because factor 2 is going to be purchased by firm 1. So firm 1 pays for factor 2, and firm 2 will also be paying for factor 2. So factor 2 incomes will be originating from firm 1 and firm 2. Okay? Now, consumer's income. Consumer's income originating from where? Look at consumer 1. So consumer 1 will have factor 1 and factor 2, right? These are endowments. And consumer 1 will sell these factors to firms. So income of consumer 1 will be originating from factor 1 and factor 2. Similarly, incomes of consumer 2 are originating from the selling of factor 1 and factor 2 to the firms. Okay? So then what happens? We are done, right? All these other entries will be 0 because there's no income or expenditure there. Okay? And now for the numbers, in the specific example, you have these, depending on the input-output matrix, and your production function parameters, your utility function parameters. If you solve the model, that was your assignment, that was your exercise, you must have done that. So you find these numbers, okay? So there's 40 here, 10 here, 10 here, 15, 30, 20, 20, and 5, okay? Now, as you see, I have now all the transactions in numerical units. And what is going on? Now, as I said, incomes must be equal to expenditures, right? So let's look at firm one. This is the expenditure, right? So firm one will spend 20 units to itself, 30 units to firm two. Why? Because again, there is this intermediate input demand. Then for the first factor pays 40 units. For the second factor pays 10 units. So the total here is what? 100, right? Now this must be equal to, this expenditure must be equal to the firm one's income. And look at the number here, 20, 70, 85, 100. Now look at firm two. Firm two spends 50 units to firm one. That's the intermediate input demand. 25 units for its own product. 10 units for the first factor, 25 units for the second factor. Okay, so what's the total here? Again, 100. So this must be equal to, this is expenditure of firm two, must be equal to the income of firm two. What's the income? Look at it, it's 100. Okay. Now, factor two income. So sorry, factor one income, 50 units. Now, factor one income is originating from firm one and firm two because firms are paying for this factor. Then this account's expenditure is going to consumers, right? Consumer one obtains 30 units of income from factor one, and consumer two obtains 20 units of income from factor one. So 50 is equal to 50. Okay, same is true for factor two. The total income recorded for factor two account is 25 units. 20 units of this is paid to consumer one. 5 units of it is paid to consumer two. All right. So once again, the income total will be equal to expenditure total. So that's how it works. All right. Of course, once you extend the model, once your model becomes more realistic, then this social accounting matrix will be larger. There will be many different firms, many different industries, factors more than two, consumers, different types of consumers, consumers of different ages, consumers at different regions, okay? And there will be government, there will be tax accounts, there will be capital account, and if you open up your economy, there will be import account, export account, and then the current account, and then the international capital flows. So we're gonna see that possibly in the next, because today we're gonna spend some time on introducing government and taxation, but that's how it works. So that's the basic logic of social accounting matrix. All right, all the agents in the economy, their transactions, both from the income side and the expenditure side, are going to be recorded, and at the end, incomes will be equal to expenditures. Okay. So, any questions about the logic of the social accounting matrix? Okay, then. So now we can study taxation. So this is chapter 4, all right, in your text, and we're going to study different types of taxes. First, we're going to look at an indirect tax. So the idea is this. Of course, there are different types of taxes in the economy, right? There are ad valorem taxes, excise taxes. So if you, let me just remind you that if you tax the number of units that are traded, this is usually called an excise, a unit or excise tax. Okay, and if you tax the volume of transaction, basically, okay, the monetary value of transaction, it is called ad valorem. Okay, now what we're going to look at first is this. Remember the cost concept, right? Average cost. Now we're going to put some tax rate tau to the average cost. So let me be more specific here. This is VJ. Then this is the total amount paid by the firm, right? This is firm J paying for factors. You must be remembering that. Okay? And then this part from 1 to n is paid to the intermediate inputs. Remember that? So this is, so in the original model, we had Tj equals 0, right? So tau j, so this is tau, a Greek letter. So tau j was equal to 0 for all j, okay? So no firm was taxed, okay? So that was true for all firms. Now in this version, we tax the total use of inputs, both the primary factors and the intermediate input, because this becomes the average cost, right? So when I tax the firm, I basically increase its cost in this way, okay, by using the tax rate tau. Because originally it is just equal to this. If I put a tax rate, so here tax rate is between 0 and 1, okay, I basically increase its average cost. So you may imagine that let's say the tax rate is let's say 20%, right? So the average cost then increases 20%, right? Originally it was just this. Now it is 1.2 times that. Okay. Now, of course, you should ask, what does the government do with the tax revenue, right? And here, we're gonna distribute this to the households. Okay. So once again, of course, the equilibrium will require, you should be careful with that. Equilibrium is still characterized by zero profit condition. Okay, don't forget that. So this must be still true for all firms, right? But now tax rates are exogenous, and in fact, be careful, tax rates can differ across firms. Okay, so government has the freedom to tax different firms at different rates. Why would a government do that? Well, sometimes, for instance, if this is an environmental problem, if some of the firms are using dirty technologies that emit carbon dioxide heavily, and some other firms are using green technologies, an environmental orientation. So if the government is environmentally oriented, then the government could be taxing the firms using dirty technologies by higher tax rates so that they can limit their production level, and they can give some subsidies to the green technology firms. Okay, so that depends on the problem you are studying, the reality of the economy. Okay. Now again, the government, since this is a general equilibrium model, this tax revenue, okay, there is this tax revenue, right? Because some part is paid for the factors, some other part, depending on tau, the tau times this will be paid to the government. So since this is a general equilibrium model, we should ask, what does government do with this money? Because that money should go somewhere. Okay, because again, this is a general equilibrium model. We have to keep track of these transactions. So we're going to assume something like that. Tax revenue will be given to consumers as a transfer. Okay, so that's our simple assumption. Okay, and we're going to do something like this. Remember, we have, in the general case, we have 8 different households or consumers, right? We're going to assume something like that. There will be some transfer shares, okay? There will be some transfer shares. So delta H will be the share of tax revenue that the household H receives as transfer. Okay, so if you imagine that, if for instance delta H is 0.2 and in total there is a tax revenue of, let's say, 100 units, then 20 units goes to H. Okay, so you may, so there is actually now a vector, right? Delta 1, delta 2, dot, 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 delta H. So the total of them is of course 100, is of course equal to 1. Why? Because the entire tax revenue will be distributed to the households. But this also can differ across people. Why? Well, perhaps some households are poorer, some consumers are disabled, some of them are unemployed. So the transfer scheme can differ across people. Okay? But if that's the case, then income will differ, right? Remember, in the original model, we write the consumer problem in this way. There are goods that the consumer consumes, okay? So there is CIH, right? And this must be equal to the income basically originating from all the other factors. Right? So there are factors and there are factor prices and there are endowments. Something like that, right? Now, what's happening? Well, now we have this transfer income. Okay? Now we have the transfer income, and let me check. Yes. So we're gonna use, let me just correct this. We're gonna use T for the transfer. Okay, T for the transfer. And then the household budget will be looking like this. Why? Because now the government simultaneously taxing the firms and using this tax revenue as transfer income for households, and each household age. So this is for household age, obviously, right? This is for household age. the total transfer income this household receives depends on the weight that the government determines for this household. Okay. Now, at this point, we should be also specific about the revenue. Okay, so R will be tax revenue. And be careful, this is endogenous. Okay, why? Because tax revenue, how do you write that? Well, there is this firm, J. We are taxing the average cost of this firm. So this would look like this, right? Again, from K to K, we have omega K, BKJ omega, plus there's this intermediate input demand, right? We have the price and the input-output coefficients, remember. Now, this is the unit cost, unit average cost. For total cost, I write this, right? So let me be specific. So this is unit average cost, or basically just average cost, right? So this is, let me be careful here. So this is average cost pre-tax, before the tax, okay? This is average cost before the tax. This is total cost before the tax, pre-tax, okay? And then this is total tax paid by firm J, right? But then in the economy, there are N firms. So I take the summation. So this becomes your revenue. Okay? So you should be careful with that. And now you understand that it is endogenous, right? Why? It is endogenous because it depends on three things. It depends on factor prices, it depends on product prices, and it depends on the output levels. Okay? So we better write R, P, omega, Y. Okay? So that's the notion. Tax revenue here is endogenous. Okay? So this now is, of course, total tax paid by all firms. Okay? So now we have less than 2 minutes. If you have a very quick question, let me answer it. Or we're gonna take a break and we're gonna meet for the second hour. Any questions? Okay, then. It is about 12.
What time we will start again?
Let's say 55, because it is around 12:40. The video conversion takes about 15 minutes. So we're gonna meet at 12:55. Okay?
Okay.
All right, then. I will see you in like 15 minutes. I'm ending the session now.
Okay.